time, I think we should go ahead and get started. So this class is now being recorded, and let's go. So today's devotional is Colossians 3:23 through 24. Whatever you do, work heartily as for the Lord and not for men, knowing that from the Lord you will receive the inheritance as your reward. You are serving the Lord Christ. So remember ultimately who you're doing your work for, and that there is a higher purpose. So, and then we have Psalm 90:17. Let the favor of the Lord our God be upon us and establish the work of our hands upon us. Yes, establish the work of our hands. Again, two related verses in terms of who we're working for and why it's important to put in your best effort. Okay, so administrative items, we're getting smaller and smaller now. So the extra credit points for the Chapter 12 programming exercise is due Monday. It's not really so much a programming exercise as it is in learning about how to use symbolic links in Linux. So it's good exercise because symbolic links are a valuable tool that you can use, especially when you're scripting things. One example of using symbolic links is when you're setting up your Java platforms. If you're doing multiple versions of Java, like say you're doing Java 8 development and Java 11 development, that you can use symbolic links to link to the correct compiler and then put in your class path or your path for executing binaries, a symbolic link, and then just flip the symbolic link to point to whatever version of Java you'd like to use. So that's one example of where symbolic links are valuable and that are provided by the Linux operating systems, and most other operating systems have something similar. So that's a good exercise to do. So it's not strictly a programming exercise, but walking through the steps of learning how symbolic links work. And then Tuesday, the day before our scheduled final, the remainder of the quizzes are due, and that's chapters 10 through 14. Please take them early as possible so that you don't get this mad crunch at the end. And again, that is part of being exempt from the final for this class, is having no zeros, and finishing up those quizzes would be part of that. And again, also you can go back and revisit assignments that you have zeros on and get partial credit for turning in them in late and qualify for exemption of the final. And then I don't know how many revolve this, but so there was a bit of problem with the NAS storage programming problem, and actually I was seeing this also on the Denying Philosophers, and that was people copying code directly from the internet. They found that they thought was closely related to solving the problem that was being asked, and in fact, with the mass storage program, it was, I think, targeted specifically at that problem, but it was obviously an error, and I gathered that students didn't know enough about what they were copying to even notice that there were all these errors in it. And I started seeing the same errors over and over again, and then notice, hey, this code is written exactly the same between all these different students. So I would definitely recommend that instead of doing that, that you come ask me or one of your fellow classmates, hey, I'm having problems. Can you give me a hint, or can you guide me and walk me through what needs to be done, rather than just copying code blindly from the internet? Because these are skills you will need as a programmer. You will have to figure out tough programming problems, and you won't be able to just copy it from the code. You'll have to be able to develop an algorithm and a strategy for solving various problems. So I probably won't. I was thinking about discussing sort of an outline of the project Maybe if we have time at the end of the lecture, we'll do that. But you're welcome to stay after lecture if you'd like to discuss that programming assignment as well as anything else, or schedule a time, some other time as well, with me to meet online. Seems to be pretty useful to actually be able to share information. So we were talking about rights and privileges and how that is handled in an operating system. And we were talking about domains. So we talked about how the most common domain access usage is by the user account. The user ID is associated with domain or domains, and privileges are granted via those domains. But it can also be the process or a procedure as well. But again, remember that the user ID is the most common form of identifying domains. So here we have domain structures. So you have 3 domains, D1, D2, and D3. And as part of each domain, they're given various privileges. So on object 03, 1, and 2, we're giving various permissions. On 03, you get read write in domain 1, but only execute on 02. And then you can see that in domains 2 and 3, that there's actually overlap between those domains, where object 4 has print capabilities for both domain 2 and 3. So again, the access given to domains does not have to be mutually exclusive. You can have multiple domains that have permission to do various operations. So one implementation is that of Unix and /Linux. So the domain is the user ID. They're one and the same. A domain associated with the user/user ID in Linux and Unix. The domain switch is accomplished via the file system. Each file has associated domain bit set, and when a file is executed or being used, those bits are executed and checked to make sure that the appropriate access permissions are available. When execution completes, the user ID is reset. So you can actually have, and I talked about this a little bit earlier, in the Linux Unix world, you can actually change domains in order to do specific operations, sort of like an escalation of privilege. And the technique used in Unix is the SU command, which is a substitute user, is what SU stands for. And it's a temporary switch to another user's domain when the other domain's password is provided. So it allows you to access things that you normally wouldn't have access to in your current domain. You can switch to another domain. And I did mention how super user is a common one, which is root access. You can be doing administrative things that you need it to do with super user or root privileges, but you don't want to be operating in that mode all the time. And so you would switch out of that when you're doing your day-to-day operations and only use it when you absolutely need to do it and for precisely only the things that need it, but not stay in that mode for very long. And then the other one is sudo, which is you've seen before. It's a access list that provides command execution for a bunch of different domains. And again, it's password enabled. You have to have a password associated with for the sudo command, and you saw that explicitly with the kernel mods that you were doing in the Chapter 2 programming assignments, where you're actually having to switch into a privileged mode in order to see some of the kernel information. So one way to view protection is an access matrix. We can see here on the top are the list of objects. So we have F1, F2, F3, and a printer. F1, I would assume, looks like it would be a file based on the fact that we have read, write, read, and execute. So these are 3 files, I assume. And then domain 1, 2, 3, and 4, and what privileges they have for each of these resources. So you can see here that domain 2 is the only one that has the privileges to print on the printer in this particular access matrix. Notice how it is sparse, that you do have information where no rights are granted and they are left blank with no access or no privileges on that particular object. So something to keep in mind in terms of how you might go about implement such an access matrix. So this slide is basically just what I talked about on that diagram about having specific rights to the various objects. And again, we have the owner of the actual object and has control over that domain in terms of what privileges are being allowed to other users and other domains. So access matrix is separating the mechanism from the policy. The mechanism provides access via a matrix, ensures that the matrix is only manipulated by authorized agents. So typically that will be the owner or root, and these rules are strictly enforced. That modification of who has access should be tightly controlled to provide the appropriate security. And then certainly the policy that you're trying to implement will dictate the access matrix policy and how things are configured. And just a note, the text says it doesn't solve the general confinement problem. That we will not discuss too much in class, but the text goes into that a little bit, I believe, the general confinement problem and what that means. Again, this seems to be just a repeat, but we actually have the addition of actually having domains added as objects in the list of objects. And so here we have the capabilities of which of these domains are allowed to be switched to another domain. So you can see here that domain 1 is allowed to switch into domain 2, but only domain 2. And we can see here that domain 2 is allowed to switch to domain 3 and 4, etc., looking at the matrix. So we can actually add domains as objects into the matrix to add extra flexibility and capabilities in terms of granting and or excluding privileges. So I talked about that generally the access matrix is a sparse matrix, that you have certain players where that it's there's not any capability, and the table can get quite large, and so it wouldn't fit in main memory for efficiency purposes. So there are other ways beside a global table, and so another one would be an access list for the objects, often referred to as an access control list. So one thing here to note in the global table for the option here on option 1, that the information for the global table is stored as an ordered triple. So it's a tuple of 3 items, so hence a triple. And that is the domain, the objects that if you kind of view the matrix here, we can see here that what we're talking about is this side and then this side, and then we're talking about what's in the box. So we have the domain, the object, so that's the cross section of the table, and then the right set. So those are the values that are in the table values. So that is the 3 values, and that can be stored in these sets of tuples or triples, tuples with 3 values in a global table using an ordered triple. The other access method is option 2, which is an access list for the objects. That each object has associated an access list, which is a domain or a rights list. So again, tying the access to the actual objects and then having a list that provides the domains and what right sets those domains have for accessing that particular object. So key things I want you to remember from this slide is the triples that are involved with the global table, and that in general, the access list is a sparse matrix. And so we look for ways to most efficiently store and the access matrix in a way that doesn't consume all your memory or all your storage capability. Another way that this can be executed, so those were 2 options. Option 3 would be a capability list for each domain. And so there we're flipping it around and saying each domain is given a list of capabilities that it is able to use. And so there are the objects together with the operations allowed on them are stored into capability lists for each of the domain. And so the domain actually holds what capabilities they have. But of course, you need to control who has access to updating and modifying the capability list. You don't want the domain members of the domain to necessarily have direct capabilities of modifying the capability lists, their own capability lists. So again, it's maintained by the operators and accessed indirectly, like a secure pointer. Again, there's great security options available or needed for providing a capability list for a domain. And then the other mechanism, I think a lot of you who have taken computer security or are majoring in computer security are familiar with this, is having locks and keys. And so this is a compromise between lists and capability lists, where each object has a list of unique bit patterns called locks, and each domain has a list of unique bit patterns called keys. And therefore, a process in a given domain can access the object if it has the appropriate key to unlock the lock. Note that in this scheme, that users are not allowed to examine or modify the list of keys or locks directly. They depend on some other process or other domain to actually grant them keys and to present what keys they have, to examine them or modify them or add them or delete them, etc. So yeah, keep that in mind, that you do have to have access, control over the locks and keys, and exactly how the locks and keys would be used in the access matrix. And then, of course, another approach you can do is a hybrid, and you see this as sort of a theme in operating systems where we try to take as much of the benefits of multiple approaches and try to merge them together into a hybrid technique. And so most systems actually do this, where they do a hybrid of access lists and capabilities. So you have a combination of the two. So capability list is used for localizing information for a given process, though it can be localized for that process and that domain. Downsides of capability lists is revocation capabilities can be inefficient. And then the lock and key is effective and flexible, but keys can be passed freely from domain to domain, and easy revocation can be accomplished by just changing the locks and not giving the process the new key. So that can be commonly done. But again, this last bullet here, which I said earlier, is that most systems use a combination of access lists and capabilities, but these are the various trade-offs to consider in these different approaches. But access lists and capabilities, a combination of the two of those, is the most common. And ACL stands for Access Control List in this bullet here. So access control, the protection can be applied to non-file resources. You know, most common cases that we see this in using an operating system is files, but it can be applied to non-file resources. And in our example, we actually, I think, had access to a printer as one of the items in the matrix. And then we have Oracle provides role-based access control to implement the least privilege, again, using that capability that we want to try to give each domain the minimum amount of privileges that they need in order to do their job. And so Solaris used a technique called role-based access control to implement these privileged assignments in the best way, and to have that fine granularity to allow us to limit it process to the absolute minimum, or the as much of limited access to only the things that they need as we can possibly can. So that was Solaris's solution to that, or is Solaris's. So revocation of access rights. There's various options for removing access rights. They can be immediate or delayed. So they could be put on a queue and say, okay, we will get to it. Or the other thing, and also you could have some kind of a background process that's processing the revocation. So you can either do it immediately or have it delayed. It can be selective versus general. You could say, okay, we're going to wipe out all the permissions in for these domains, or we can just say only these particular domains will have the rights revoked or changed. And then partial versus total, and then temporary versus permanent. You can also have a situation where you grant access rights temporarily, but then after a prescribed period of time, those rights go away. So for access lists, to delete access rights from an access list is simple. You search the access list and remove the entry from the list. So again, that's a fairly straightforward operation that you've seen in your data structures classes. They can also be immediate, general, or selective, partial, permanent, or temporary. And one way that I think we will come across in a later slide is you could actually have it so that rights are temporary, and there is a process that periodically removes privileges, and then from everybody, and then periodically those rights then have to be reinstated as a way of continually managing access rights. Capability lists are, so actually this is the slide I was actually talking about. Capabilities list scheme requires to locate capability in the system before capability can be revoked. Reacquisition periodic delete, which requires a reacquisition of the right, and if you don't get the write back, it's denied. We can do back pointers, which is what Multex, which is an old operating system that had some pretty novel concepts in them. It's Multex with the back pointers, and then indirection, which is capability points to a global table entry, which points to the objects, and then delete the entry from the global table. And then keys. There's the master key is associated with an object key matches master key for access. Revocation, we create a new master key, and then the locks are modified. And then the key decisions is who can create and modify key, and who actually is the owner for permitting or denying access to that particular resource. So again, here, this is the method that I was talking about in terms of reacquisition, which are periodically deleted from each domain in the reacquisition scheme, and then in order to continue using that right, you have to be granted the right again. So examples that are discussed in your text regarding capability-based systems is Hydra. And again, we won't go too much into this, but one particular thing of note, it solves a problem of mutually suspicious systems, which is that you trust everything within your subsystem, but everything outside of your subsystem you are suspicious of. And this was the scheme that was used in Hydra in order to provide this nature to the security. In terms of capability-based systems that was introduced in the Cambridge CAP system, it's simple but powerful, and it has these particular capabilities in terms of data and software capability. But here we have to keep in mind that programmers must learn the principles and techniques of permission to use this system well. But again, that's probably the depth that we will go into it. I'm pretty sure the text goes into this in a little bit more detail. And then we have language-based protection. Specification in the protection is actually provided by capabilities of the language or features of the language. The language can provide software protection enforcement when automatic hardware support checking is unavailable. You interpret the protection specifications to generate calls on whatever protection system is provided by the hardware and the operating system. One example that I'm sure you're all familiar with, and I actually looking forward and seeing that that's my next slide, is that protection in Java is handled by the Java virtual machine, and access to all resources is mitigated through the Java virtual machine. And this was the thing that was to provide the capability to have code running local from web applications. There was the difficulty in that it was difficult to test the environment, so that aspect of it has kind of gone away to a great extent. But that was the idea, is that you were contained in what you had access to by the Java virtual machine. So a class is assigned a protection domain when it is loaded by the JVM, and the protection domain indicates the operation the class can and cannot perform. If a library method is invoked that performs a privileged operation, the stack is inspected to ensure that the operation can be performed by the library, and that you aren't trying to do something malicious through that library method. And generally, Java's load time and runtime checks enforces this type safety. And in particular, it was one of the languages that emphasized, compared to C and C++, the enforcement of memory and not being able to access memory that you didn't have or weren't rightfully should rightfully be allowed to access, that we did protect memory from spurious or intentionally non-privileged access to areas of memory. So that was kind of the scheme that was envisioned with the Java virtual machine, and that was its role. So any questions about this material or the class or the assignments coming up? All right, so let's go to the mass storage programming problem. So the mass storage programming program, and for those of you who successfully completed it, congratulations, good job. So for those of you who stayed after and asked me about the programming problem, I gave the hint that for some of these, particularly some of these algorithms, that sorting your list or your data structure would be advantageous in actually implementing. So some of you got that, especially if you stayed after class. I think it actually was the last class. I can't remember exactly which class it was, but had some students stayed after. My hint was that sorting them in cylindrical order could make the job easier of actually implementing this. Another hint that I will go ahead and add to that and give to you that are still struggling with is that if you choose to not use C, and you can still use C and it still works. And I had one student that actually used it in array and used a -1 to indicate that a particular request had been serviced. Whenever it had been serviced, a -1 was replaced the cylindrical value. So that was one approach. But the other thing is, if you decide to do this in Java or C# or Python, you do have array lists in Java, vectors in C++ or C#. I think both of those. And I can't remember off the top of my head what it is in Python, but you do have a list type structure. And the advantage of using that a list type structure is, first of all, you don't have to implement your own sort routine, even though creating your own sort routine is no big deal. But certainly those languages, in particular with Java, you have the collection sort method or sort. I think array list actually has sort built into it, but you can actually sort that directly using the language libraries, which is nice that you have a well-tested and vetted algorithm for doing it rather than doing it yourself. And certainly as you get into the workforce, I would recommend that you do so. Take advantage of some of the libraries and language features because they have been so well tested, and so it is less likely to be a source of error down the road in your implementation, taking advantage of something that's built into the language. But the other advantage of using an array list or a list is that, for instance, in the shortest time first algorithm, you would actually take your current position, either one of your requests or your initial cylindrical position. And so let's say you're doing your original cylindrical position. You could actually just add it to your list and then sort it into your, maybe not. You could sort it into the list, but you'd still have to keep figure out where in the list that object is. So maybe that's not the best approach, could or could not be. But the other way you could do it is walk from the front going up until you have a cylinder position that's greater than the cylinder position that you're starting at, and then start there as your location in your list when you're going to start looking for the shortest. And then what you can do is, once you found that position where you're below it, you know what's behind you because you just traveled through it. And then you could look to the going forward in the list and going back in the list and say, okay, which one is the shortest distance? You calculate that and you say, okay, that is going to be my next location. You move to that next location and then delete the list location, the location in the list, the element in the list that you're currently at, because you've already serviced that request. You know that that request has been serviced, so you can take it off the list, and now you can just go forward and back again. Now, please remember, you do have those boundary conditions where you're at the beginning of the list, and there isn't any value before you, and so that tells you something that now you can just keep going forward through the list, because everything, it now becomes a scan algorithm where you're just going up through the list because there isn't anything behind you that you need to compare. So it quickly becomes the scan algorithm. Shortest time first becomes that. Not that you have to change your algorithm, but that will be the behavior. So you have that end condition, and then you have the end condition when you've come to the end of the list and there's nothing after you, but there may be something in front of you on the list. So that is another approach, is to use an array list in Java or a vector in C#, C++, or some other data structure. I had one person tell me, hey, could I use a binary tree? Yeah, I'm sure you could come up with a way to use a binary tree. It might be a little bit more complicated, but certainly think about this in terms of what you have learned in your data structure classes of how you would address this problem. Because, this is not necessarily a problem that you will have to solve when you get in the workplace, but you do have to constantly learn how to come up with algorithms relying on things that you've learned in your other classes, data structures, and working through and coming up with a design of how you're going to approach it. So there are other approaches. That's just one of the approaches that came first to my mind. And so for those of you who haven't turned in your assignment, think about some of those things. And if you want to stay after class and discuss this programming problem or anything else related to class, you're free to do that. But we have actually made it through all of the material. So for the next lecture, for the next class, there will not be a next class because we've gotten through all the material. I will be online for, let's say, the first 15 minutes automatically. I will be on the team meeting, and you're welcome to ask me any questions you have about the class or about some of the assignments that you're having difficulties with. And but you're also certainly welcome to reach out to me by phone call, email, or chat. Probably the quickest and most efficient way would be to call me on my cell phone, which is listed in Canvas under the teacher information section, and I think I have it other places as well. But give me contact me, and then we can arrange and set up a time if I'm not available exactly at that moment to discuss whatever issue you're working through. So with that, I will go ahead and dismiss people, and feel free to stay on the line if you have a question that you would like me to address.